Right, students, so let's start today's class. Small class today. Small class, why? Because we have to do certain portions that we could not do in these 4 days, right? What was left is friction and friction in circular motion. So those things we are going to see today. So friction, it is a part of laws of motion, right? So friction basically is what? Friction what is friction? A force that opposes sliding motion. That opposes sliding motion of one object on the other. Sliding motion of one object on the other. Now the question is why it opposes? The reason is because two surfaces are not smooth. They have irregularities. Like one surface will be like this and the surface above it will be like this. Okay. Now if I make the surfaces also, let's say this is block 1 and this is block 2. Okay, so there is locking. So when you are going to push this one here, so what it has to do? It has to overcome this locking before. So the force required to overcome the locking, we call it as friction. Okay. Force or force minimum required to overcome the locking or interlocking is friction. Okay. Now two types of friction we have, static and kinetic. Okay. So static and kinetic. A kinetic friction is constant. This is constant. Whereas static friction varies. It depends on how much force you are applying. Okay. Static force, or static friction force varies between zero and its maximum value. Maximum value we call as what? Limiting friction. Maximum value of friction we call limiting friction. Okay, so static friction varies between 0 and limiting friction. Now how to decide? How to decide whether we have to take 0 or we have to take limiting friction? So limiting friction only is what we define here, minimum force required to overcome the interlocking. Okay, when we talk about static means what? Static means this object is at rest. Object is at rest. Then only static we call. So when the object is at rest and you are applying a force F over here, and if suppose it is able to overcome this locking, that force will be equal to maximum value of friction, maximum value of static friction. Okay. Kinetic means what? When we are talking about kinetic, it means object is already in motion. Object is already in motion. So when object is already in motion, we know that locking or interlocking will not be proper. Okay, it will not be proper. So the force required to move this will obviously be less than what is required to start the motion. That's why we always say that kinetic friction value is kinetic friction value. Kinetic friction is always less than maximum value of static friction. maximum value of static friction. What is that? Limiting. Maximum value of static friction, which is called limiting friction. Okay, but still that thing is not clear whether we have to take the 0 or what. Okay, how it's going to vary. So let's see, let's try and understand that. If we assume there is a block like this, okay, and you apply maybe let's say 1 Newton force, or you don't apply force initially, okay, no force is applied, and this block you say is 2 kg, no force we applied, is it moving? No. So then which force is, or how much force is stopping it from motion? 0. You didn't apply any force, so friction also will be 0, right? So here force of friction is 0. Because we have not applied any opposition force. Now suppose another case, same 2 kg block, we applied force F equal to 1 Newton, but still it is not moving, it's at rest. So what is the friction here? So question is, who is opposing it from moving? It has to be friction here. So here force of friction value is 1 Newton. So it means it is equal to the force which you are applying. Okay, maybe next time when you apply 2 Newton, still it is not moving. So if it is still not moving, means friction is 2 Newton. And this kind of a thing keep happening, maybe till 5 Newton you apply. Now you apply 5 Newton, and what happens? This block, okay, you are just able to, like, it is able to move from its place. It's not that you can continuously move it, but at least you can displace it a little. So then we will say that maximum value of force of friction is 5 Newton. Okay, at this force, what happened? This force block starts moving a little. Not that the start moving with velocity, but still you are able to shake it, or you are able to displace it. So we said that maximum value is 5 Newton. So this is limiting one. So you can see that same block is there, but force of friction 0, 1, 2, 3, 4, up to 5, it was varying. So this is all static friction, because still block has not moved, static. Okay, so static friction, force of friction static is actually equal to force applied to move the block. Okay, till what? Till force is not greater than, till F is greater than force of friction limiting. Okay, force of friction static will be equal to force applied to move the block till this applied force is not greater than force of friction limiting. Once you apply greater force than that, what will happen? Block will start moving. Then force of friction will become kinetic friction. Okay, if force applied is more than limiting friction, then force of friction is kinetic friction. Okay, clear? Now let's make its graph. How is the graph? Let's see. So if we make the graph, alright, so So we are going to make the graph here for friction force. Okay. Initially what we said, force of friction static is equal to force applied. So that means it will be a straight line like this, 45 degree. Why? Because it's equal. Here is force, or this is force of friction, and this is the applied force. Okay, so initial angle 45. Suppose this itself is maximum value, limiting. Now what will happen? If you increase the force more than this, what will happen? It will start moving, and then again force of friction will decrease. Okay, so it will be like this and become constant. This is kinetic friction. Okay, whereas this one is what? Static, from 0 to maximum value. Okay, this is the graph of friction. Now let's see how to find maximum value. Okay, this all we know, that how much force you are applying, that only is friction. But how to find maximum value? What is maximum value of static friction? Okay, so what it is? Force of friction limiting, that is equal to mu n. What is n? N is normal contact force. Normal contact force, and this mu is also mu s, we will write mu s. Mu s is static coefficient of friction. Static coefficient of friction. This is maximum value of friction possible. Same way, if suppose kinetic friction we want to find, kinetic friction is also mu n only, but in that one mu becomes mu k, and mu k is less than mu s. Remember, mu k n. So what is mu k here? Coefficient of kinetic friction, or kinetic coefficient of friction. Kinetic coefficient of friction. Okay, and mu s is always greater than mu k. This is how we calculate limiting and kinetic friction. Okay, and the most important one, how force of friction is equal to the force applied till the force is less than limiting value. Very, very important for us. Okay, and let's see then what more are there. There are certain more values that we should remember, more theory about that. What is that? Angle of friction. Angle of friction. What is angle of friction? If this is the block, you applied force like this. So we know that force of friction will be where? Force of friction will be acting the back. Force of friction will always be along the line of contact, because force of friction is tangential contact force. Okay, what force is friction? Tangential contact force. Tangential contact force. So it's always along the line of contact. Friction will be this side, because you are pulling from this side, friction will be acting back side. Here normal contact force, and here will be mg. So two types of contact forces are there, one is normal and one is tangential. So resultant contact force will be here, that's R. So angle of friction is this, suppose theta. Okay, angle of friction is theta, that means angle between normal contact force and resultant contact force. Correct? Now tan theta will be what? If you see this, if force of friction I replace at the top here according to the parallelogram law. Okay, so if here I am going to shift this force of friction, then tan theta will be force of friction by n. What will be tan theta? Force of friction by n. Okay, and if I say that this force of friction here is limiting friction, that means this much force you are applying, So in that case, tan theta is equal to what? This will become mu n by n. So tan theta equal to mu. So angle of friction is actually equal to tan inverse mu. So sometimes they only give you angle of friction and they don't give you mu value. So how to get mu value? We should know this relation, then only we can get it. Okay, so this is also important, right? So this is angle of friction, angle between normal contact force and resultant contact force. Clear? Okay. So this much theory is there. Yes. Now let's solve few problems on that. Let's start solving problems. Okay. So see now what type of questions we can do and how to start it. Right? Okay. So here it is. Suppose this is 5 kg and coefficient of friction here between them is 0.4. Now when only 0.4 is given, means in this case static also for 0.4 and kinetic also 0.4 we have to take. Okay. Alright. So now the force that we are applying here is 10 Newton. The question is, find friction force between block and ground. Okay, so how to find it? Ways, first let's find out how much is the maximum force, maximum friction force. So maximum friction force is mu n. Maximum force of friction is mu n. And what is n? Here is 5g. This is n. So n value is 5g then. Correct. So let's put it. This is 0.4. This is 5 and g, that is 10. That means 20. So maximum value is 20. Is he asking maximum value from us? No, he is asking friction force. So how much force you are applying? 10. Will this block move? Friction force is 20. Will this move? Answer is no. Then how much is friction? So if you are applying 10, how much force is required to stop this block? 10 only. So friction force will be 10. Okay. So force of friction here in this case is 10 Newton only. As I told you that till this force is less than force of friction will be, rather till this force is less than maximum value of force of friction, then force of friction will be equal to the applied force itself. Okay, right? Now if suppose in place of this 10 I make this as 25, and your question is find friction force between block and ground and also find acceleration. Okay, and also find acceleration of block. Okay, what to do now? We know that maximum value of force of friction is 20. How much we are applying? 25. When 25 you are applying, that means it's going to move. There is no doubt about that. Correct. So static friction is 20. What is kinetic friction? That is also 20. Why? Because mu k and mu s both are given same only. So in this case kinetic friction will be equal to static friction. Okay. So if I write the equation over here, force is acting in this direction, friction force is here at the back, and then we can say it's moving with some acceleration a. Okay, it's moving with acceleration a. So what we can do? 25 minus force of friction 20 equal to 5a. 5 equal to 5a. So acceleration is 1 meter per second. Acceleration is 1 meter per second square. Is it clear? I hope it's clear to everyone. Okay. Right, students. Then next one. Right. Now see how we are applying the force. The same 5 kg only will take. This time force we are applying like this. Okay, and this angle you take is 37 degrees, and this force is, how much shall we take? 25 Newton, 20 Newton we take. Coefficient of friction 0.2. Okay, question is saying find friction force between block and ground find friction force between block and ground and what else? And acceleration if possible, and acceleration of block. Okay, so this is the question for you. Now in this case what? Why I gave you this question? Because normally we say that force of friction whenever is asked, it's mu n, mu mg. Not so, not always. Okay, n is what here? Just see, this is 5g, this is n, but in this case there is component of the force. Here is F cos 37 and here is F sin 37. So if you are calculating n also, because it's not going upwards. Okay, so n value will be what? We'll write here n plus F sin 37 equal to 5g. Downward force equal to upward force because motion is not along vertical, right? So n plus F is what? 20. Sin 37 means 3 by 5, and here we can write it as 50. So how much is that? This is 12. So n value is going to come as 38 Newton. Okay, so now first of all, what is the limiting value? Force of friction limiting, say mu n only, there is no problem in that. Mu is what? 0.2. 0.2 into 38 means 7.6 Newton only. How much are we applying? F cos 37. F cos 37 is how much? 20 into 4 by 5. That means 16. 16 you are applying from here, and force of friction limiting is 7.6. That means it's going to move. Okay, so let's find how much it is. So 16 minus 7.6 equal to 5a. Okay, so 16 minus 7.6 is what? I think 8.4 equal to 5a. So acceleration will be 8.4 by 5 meter per second square. Okay, so this is how we have to find n value and we have to put it in the question, right? Okay, let's see one more. This time we'll take incline plane. One question we'll do on incline. Like this it is, and this angle, okay, take 37 only, and there is one block here. Block's mass is 5 kg and coefficient of friction here 0.4. Okay, and this force is there. The question is asking us find minimum value of force F so that block can be moved upwards. Can be moved upwards. Okay. Okay, let's see. Just a moment. Okay. So find minimum value of force F so that the block can be moved upwards. Okay. Now this question I am going to frame in another way also. What is it? Find maximum value of force F so that block can be stopped from moving down. Stop from moving downwards. Both are same questions. Same question, same answer. But see the language. First of all, because there is gravitation force acting which is trying to move it down. Friction is there, but still it is moving down. So you applied force, right, to stop it from moving downwards. Here it says that minimum value of force, how much you applied, so that you can lift it. Okay, understood that? Both are same questions. Here it's not saying that some acceleration you have to do. No, minimum force only you have to apply. So minimum force upwards means is what? Equal to the downward force. Equal to slightly more than downward force. So we will say that equal to downward force. Here what it says, find maximum value of force F so that block can be stopped. So when you can stop it? Obviously when you apply equal to downward force, then only you can stop. So both are same questions. Okay. So how to do that? See now. First thing is, if I make this free body diagram, I know that mg sin theta is acting here. Right? So mg sin 37 is acting. Where will be friction acting? That is very important. The most important thing in this question is where is friction. So where it is sliding is downwards. So friction is where? Upwards. Normally, whenever students will see this question, okay, minimum area first so that it can be moved upwards. So it is going to move upwards, so friction downwards. That's it. Everything is gone. Okay, it's not like that. Initial tendency of this is to go where? Downwards. So friction will be where? Upwards. Okay, you are just helping over here with this force so that it doesn't slide. Okay, so now that's finished. Now what is left? So now what we have to do? We have to stop it from moving downwards, right? So F plus force of friction must be equal to mg sin 37. F plus force of friction equal to mg sin 37. So which friction is there? Maximum we have to take. Kinetic only, no? You have to stop it from sliding down. It was sliding, you stopped it. Or if you are not applying this, it's going to slide. Okay. So force we are finding actually, and this is force of friction. So first of all, let's find N. N here is like this, and here component of weight is acting, which is mg cos 37. That's all? Yes, all the forces we have taken. So here is mu n, and here is mg sin theta, that is 5g into 3 by 5. And here mu is 0.4 and 5g into 4 by 5. This is cancelled, this becomes 3g. This is cancelled. So 4g into 0.4, that means 1.6g. 1.6g will go that side. So F equal to 3g minus 1.6 g. That means our answer is 1.4 g or 14 Newton. Okay, so this is the question, right? So important question this was as far as friction is concerned, because direction of friction is very important over here. And moreover, friction is self-adjusting, you all know that. So it acts like wherever the sliding is there, it acts opposite to that, right? Okay. Another question, let's see. Here is one block, another block is here. Coefficient of friction here is mu. Question asks us, and this is smooth surface. Here also we can put coefficient of friction, but standard question, in a standard question this is taken as smooth. Okay, so what do we want now? Find minimum value of force F so that smaller block does not slide down. Smaller block does not slide down. Okay, so what's happening here? This force you are applying horizontal, but this is not coming down. Who can stop it? Now only one force is there. If at all this want to come down, this wants to come down because of which force? Gravitation. And both are in touch. Both are in touch means only one force can stop it. And what is that? Friction. From sliding down. And if friction is going to stop it, then normal contact force has to be there. Then only friction will act. No. So that means this contact should not be broken. Right? This contact force should be there. Where is contact force? Here. Like this is N. So the question is N equal to what? Yes. Pseudo force. So how to find pseudo force here now? First thing is, when we are saying this is not going to slide down, that means both of them are going to move together. So force of friction we can say is equal to M plus M into A, because both are going to move together. Okay, this acceleration will be A. As it's smooth, it has to move. So acceleration is F by M plus M. Now we can say that yes, this is a car and this is passenger. So on the passenger obviously there will be friction, or rather not friction, pseudo force. And pseudo force will be acting in opposite direction to the acceleration of the car. Car's acceleration is forward, so pseudo force is acting backwards. And what is the pseudo force value? Mass into acceleration of car. Mass of the passenger into acceleration of the car. That is only pseudo force. Yes. Now we got N value. N value is MA. Okay. So here what we can say? We can say mg must be balanced by friction. Which friction? What he is asking? Minimum value of force F so that the smaller block does not slide down. So you have to stop it. This mg must stop it. Force of friction must stop this mg. So it means I should not say mg is directly equal to force of friction. I should say mg should be less or equal to force of friction limiting. In this case, it will not come down. Okay. So then what? Mg should be less or equal to mu n. When mg should be less or equal to mu n is what? Ma. So ma. Now A value. This is A value. Let's put it there. So mg, m we can cancel now first. Okay. Then what we have? G less or equal to mu F by M plus M. So then M plus M into G by mu F should be either equal to this or greater than this. So minimum value he is asking means equal to this m plus mg by mu. That's what, no, minimum. So f value should be m plus m into g by mu. Okay. This is two blocks in contact with each other. More questions? Block on block, very important. One block and there is another block over it, m, and here is friction, and you apply force F. Okay, question? Find maximum value of F so that both blocks move together. Both the blocks move together. So, okay, this is smooth. What we can do? So, both the blocks move together. The first thing that we do is, if they are moving together, then we can write it like this. Acceleration will be F by m plus m. Okay, then the question is, on this block you applied force, so this is going to move, understandable. But then why this upper block is moving? Upper block is moving because of friction. There is friction between these two. Okay, so on this block, because this tries to move underneath this one, so on this one friction is backwards, but on this one friction is forward. Action reaction. Okay, action is on one body, reaction is on other body, equal and opposite. So on the upper body, who is acting in this direction? Friction. Friction is acting. Correct? And we are saying that this is also going with acceleration A, because question is saying so. So that means friction force is taking this block with this acceleration. There is no other force. What is the maximum value of friction? So mu n. Maximum value is mu n, and it is static friction. Why? Because both are moving together static. They are not moving relative to each other. This block is at rest with respect to this block. So static. Okay. So mu n equal to ma. What is n? Now you see mg is acting here, and n will be like this. So n value is mg only here. So there is no issues. Mu mg equal to m into a. M is cancelled. Now a value is what? This. So mu mg or mu g equal to f by m plus m. Okay. So f value is m plus m mu g. Right? That is the answer. Then if we make one more question on this one with the values, here we have taken m and m. Let's have the values and see how question can be solved. Okay, so let's say here 5 kg, this is 2 kg, coefficient of friction will take 0.4 only. Okay, and force that we are applying here is 20 Newton. Okay. Newton. Okay, fine. So now what we want in this one, we want to know the acceleration of both the blocks. I am not saying both are moving together here. Find acceleration of both blocks. Find acceleration of both blocks. Okay, see then what to do. So solution, when we start, we assume that both are going to move together. Okay, assume. That means we have to prove whether they are going to move together or they are moving separately. So first we are assuming both blocks are moving together. Okay, so if they are moving together, what will be the acceleration? Acceleration will be F by m plus m. That is 20 by 7. 20 by 7. Okay, now we have to see whether this much acceleration is possible for this 2 kg or not possible for this 2 kg. If it's possible, both will move together. If it's not possible, then both will move separately. Then you will solve them separately. There is no issue in that. But first case is to find out whether they are moving together or not. Okay. So now the question is, who's making it move? Friction. Okay. So how much is maximum friction? Static limiting friction is how much? Say mu n. And n in this case is what? Mg, we know that, 2g here, and this is n. Okay, so force of friction limiting is 0.4 into 2 into g, that is 10, 8 Newton. Force of friction is 8 Newton. Correct. Now we have to see that how much is the net force acting, because this is the acceleration, 20 by 7. So is this force of friction, can this force of friction give this much acceleration or not? Let's see. So this limiting force of friction can give how much acceleration to the body? Say 8 equal to 2 a dash, a dash equal to 4. So up to 4 this force of friction can give, up to 4 it can give. So how much we require? Less than 3, slightly less than 3. Required is 3. You can give up to 4. So that means both are going to move together only. Okay. If a dash is greater than a, it means both will move together. So if both are moving together, then acceleration is this only. Then what else he wants? Acceleration of both blocks. Done. Over. So first thing is prove it that friction here can give it this much acceleration. That is what we have to prove all the time. If it can give, both will move together. But if it cannot, both will move separately. Let's see in which case they will be moving separately. Now suppose instead of 20, I make this as 35 Newton. Right? 35 Newton now. So 35 Newton means this acceleration here will become what? 5. Okay, now we have to see that whether friction can give it that much acceleration or not. So no, maximum acceleration is 4, whereas here requirement is 5. So both the blocks will not move together. Okay, both the blocks are not going to move together if a is greater than a dash. Both blocks will move separately. Now we have to find that what? Acceleration of both the blocks. Okay, we have to find. But upper one is going to move with 4 only, because on this one only force acting is friction, and the maximum force of friction is 8 Newton. So it will move with 4. But with what acceleration 5 kg is going to move, that you see now. So this is 5 kg. What force you applied? 35 Newton. And here force of friction is acting how much? 8 Newton. And then its acceleration. That's all. So 35 minus 8, how much? 35 minus 8 is 27. Okay, so 27. So 27 equal to 5a1. So a1 is equal to 27 by 5. That's all. Over. For the upper block, 4. For the lower block, acceleration 27 by 5. This is how we have to solve this. Block on block. Okay. Only 2 blocks are there in our syllabus. Both I discussed. Now, one more case is there on block on block. When the force you are applying on the upper block. You are applying the force on upper block. Same values I am taking. I am not changing the values. Okay. Force is here. F equal to 21 Newton. Friction is same, 0.4. Question is also same, find acceleration of both the blocks. So how to proceed? First we will consider both are moving together. Okay. Assuming both are moving together. So what will happen now? You will write net force is how much? 21. Net mass is how much? 7. So acceleration possible is 3. Now on this one you are applying the force. Why this is moving? Friction. So friction is here. How much is friction here? Mu n. This is n, 2g. And this is n. Now it's very important to make where is friction. Because friction on 5 kg and suddenly you start making the normal contact force here, everything is gone wrong, because friction is not on this surface, it's on this surface. Okay, so n will be 2g. So what now we can say? Force of friction's value? Force of friction's value is mu n, that is mu into 2g. Mu is how much? 0.4. 2 into 10, that is 8 Newton. Now 8 Newton and this is 5 kg. How much acceleration possible for this 5 kg? Say 8 by 5, 1.6. But here 3. Here it's saying that if both the blocks are moving together, they should move with 3. But both the blocks are how to move? Because on this one, only force acting is friction, and which can maximum take it to with what acceleration? 8 by 5, which is 1.6. Okay. So, will both move together? Answer is no. Force of friction equal to m into a dash. So, force of friction equal to 5 into a dash. That is 8 equal to 5 a dash. A dash is 1.6. Okay. So, now a dash is less than a. So, both the blocks will move separately. So, both blocks will move separately. Okay, if a dash would have come more than 3, both will have moved together. Okay, right, then if they are moving separately, then what we can do? Then 2 kg blocks free body diagram you make. This is 30, no, this is 21 Newton, and on here friction will be acting. How much? 8 Newton. Then its acceleration. What will come? 21 minus 8 equal to 2a1. Okay. So 13 by 2 equal to a1. What about this? Its acceleration already found, 1.6, because on this one friction is 8 by 5, 1.6. So lower block's acceleration 1.6, upper block's acceleration 13 by 2, that is 6.5. These are block on block. Okay, then other than this is simple questions now. Laws of motion, we saw similar questions, so we can do that way also. Here is one block, and then it's like this. and this friction 0.2, say 8 kg, this is 4 kg. Okay, find tension, acceleration. Okay, so what we can do, here is 4g. Okay, then tension is here, same way tension is here, friction will be here, then its acceleration downwards, its acceleration like this. So what we can write here, let's say 4g minus t equal to 4a. It's going down, so net force will be 4g minus t. Here t minus friction equal to 8a. How much friction? Kinetic, if it's moving, no doubt. So kinetic friction again mu n. So force of friction is mu n. Mu is 0.2 and n value, as I can see over here, this is 8g and this is n. Okay, so 8g. How much it is? 16. Okay, so this here becomes t minus 16 equal to 8a, and this equation is 40 minus t equal to 4a. Add them. Tension gets cancelled. So it's 40 minus 16, that is 24, equal to 12a. So acceleration comes out to be 2. So acceleration we got, we will put acceleration over here 2. So this is 8. So 4g, that is 40, 40 minus 8, that is tension equal to 32 Newton. That's it. Simple type of questions. Okay, so this way we can do all the questions which are asked on friction. Okay, this is how we can solve questions on friction. Now what? We will see friction in circular motion. Okay, friction in circular motion. Okay, all right. But before friction in circular motion, let's discuss that a cyclist is going to take a turn. So how much angle it will turn? Okay, you must be knowing formula only. I am talking more. Okay, now it's like this, and suppose that cyclist, this is the wheel. Okay, so how to make that? Then okay, fine, it's like this. Okay, so it's turning in this way. Now you can see that the wheel is vertically, normally wheel will be vertical. He is trying to take turn in this side. Wherever you want to take the turn, that side only will be taking the bending. So he is bending it over here, that means he wants to take the turn this side. Okay, where is normal contact force? This is normal contact force here, like this. And what angle we are trying to find? This angle we are trying to find. Okay, so you can see that there are components of n. So one component is n cos theta here, and this will be n sin theta. Now this n cos theta has to balance what? Mg. And this n sin theta has to balance what? Or give what? Centripetal force, or it has to balance centrifugal force. Okay, so if you balance it, n cos theta equal to mg and n sin theta equal to mv square by r, it will come out to be tan theta equal to v square by rg. V square by rg. Remember that. Tan theta equal to v square by rg. What is that? Angle turn by cyclist from vertical Okay, if they ask from horizontal, then what you will do? 90 minus theta. Remember that always. It will be 90 minus theta if it is asking from horizontal. Okay. Right. Now, same kind of value will come when the question will be asked for how much angle of inclination we have to give on the road when car takes turn. Okay. How much angle of inclination we will give to road when the road is designed. How much angle of inclination? How much angle of banking? Angle of banking is given. There also answer is tan theta equal to V square by Rg. Okay, so here is suppose car mass is m and this is the axis about which it is going to rotate. It takes a circle. Okay, so radius is this. This is radius. It is going to take circle like this. This will be circle. Okay, so this is radius, not this. This is not radius. This is radius. So what will happen? So mg sin theta. Okay, then centrifugal force will be here. mv square by r. Its component mv square by r. What will be that component? Cos theta, because this is theta. So mv square by r cos theta like this, right? So this need to balance it, because this should not move. Neither it should go up nor it should go down. No sliding. And here we don't consider friction. When we design the road, at that time we don't consider friction. Okay, remember that always. That is the cushion we do. We try to balance the vehicle with the slope itself. Friction will be additional, so that the safety is ensured. Okay, so mg sin theta equal to mv square by r cos theta. This is cancelled. Sin theta by cos theta and g goes there. So tan theta equal to v square by r. Remember that. Sometimes they will not give you this theta, they will say you that this is B and this is A. But okay, no problem. Tan theta is 0. B by A. We'll write B by A over. And we'll get R value. Sometimes they ask you R value. B by A equal to V square by R. Get R value. Okay. On horizontal road, okay, suppose the road is horizontal, and horizontal road you want to take a turn. Okay, so there is a horizontal road and we want to take the turn. Okay, fine, take the turn. Okay. Right. So suppose this, like this road is there. Okay, and you have a car. Here is car. Okay, this is radius, and it's moving with, let's say, velocity v. So what will happen on this one? There will be centrifugal force acting. Where will be centrifugal force acting? Like this, mv square by r. So then you require something to prevent it from moving there. It is friction. It is friction acting. So a question will be asked from you, what is the maximum speed at which you can take the turn on a horizontal road? No banking, horizontal road. So what do you say? Your mv square by r, that centrifugal force, should be less or equal to friction. Then only you are safe. Otherwise you are not safe. Okay. So mv square by r be less or equal to. Now in this case, no banking is there, no components are there. So here is mg acting directly. and that's equal to normal contact force. So we'll say mu n. Again one more step, mv square by r should be less or equal to mu mg. M and m gets cancelled. Okay, so v square is less or equal to mu rg, or v is less or equal to root over mu rg. Okay, so this is how you can take the turn safely on horizontal road, but you are taking friction into it. Correct? Now then, after that what? You have banking also, you have friction also. So in that case what will happen? You can increase your speed. You can have what is the maximum speed with which you can take the turn, and what is the minimum speed with which you can take the turn. So this is the banking, this is theta, here is car. Okay. Now what? We all know that mg is acting. Mg I am not making because it will confuse, so no need. Mg sin theta, mg cos theta, mv square by r. This also I should not make actually. Okay, fine. Mv square by r cos theta, mv square by r sin theta, normal contact force, right. This much is there. Now, if suppose you want to find maximum value of velocity at which you can take the turn. So when you say maximum, so obviously this becomes maximum because this depends on velocity. So if this is maximum, what this will try to do? It will try to take this up. Its tendency to make it slide upwards. So what will happen because of that? Friction will act downwards. Friction will be here downwards. So in that case what he will do? Mg sin theta plus friction should be equal to m by r cos theta into V max square. And force of friction is what? Mu n. What is n here? N is this, that is equal to mg cos theta plus mv square by r sin theta. Mg cos theta plus mv square by r cos theta. That's all. So this value of this will be put in this one and we will be calculating V max value. Okay. Now if suppose V minimum, so if this is minimum, that means this force is minimum. If this force is minimum, this mg sin theta will slide it downwards. In that case what will happen? In that case friction will act up. Then what will you say? Mg sin theta equal to force of friction plus m by r cos theta into V minimum square. Okay. For V minimum square, force of friction is upwards. What is value of force of friction? Same, no change. Now value, keep it over here and get the value of V minimum. So V maximum, V minimum. You don't have to remember it. These questions I have not seen are asked, but still I discussed with you this because calculation of this is not tough. You can calculate and just you have to take care of how the force of friction is acting. Okay. So this is how friction is there in circular motion and without. Okay. Yes students, so today we can talk a bit because we have little time. So this is I think 1 hour class. So are you writing the test? I have seen that many of you are not writing the test. Please write test because it's the practice which is going to take you through the NEET exam. More the question you are solving, better it is for you. Try and solve as much as possible. If you are not able to, ask me. We'll take, like today's session is there. You could have taken a session. In that one I could have taken your doubts. There's no problem in it. Okay, so keep solving the practice. I am making practice tests. I am doing a lot of effort in making it. Okay, it takes me one and a half hour to 2 hours to make the question paper, upload it, make it in a particular way so that you can solve it. Okay, so please solve. Give it a time. It's half an hour only it takes. So please solve it. Okay, see that. How is your speed? How many questions you are able to solve? 15, 20, 80. Please solve it. If you are not able to solve, again I am saying, ask me. I am here to solve it. I am here to clarify your doubts. Is it clear, students? Say yes or no.
Yes, sir.
Girls?
Yes, sir.
Okay. So please solve it. Okay. And get the time, like half an hour you have to give it for solving. It will be better for you only. Okay, and this time you know that, no, I should not say it. Okay, some other time I will say. Okay, students, then anything you want to say, you can say me. Anything you want to know, any doubts, any clarifications, anything is there? Yes, sir.
Lots of block problems, sir.
Huh.
Between the blocks, how to find direction of
That's what I said. No, you have to see where this block has to move. When you say this is M and this is small m, when you are saying this force is applied on this one and both the blocks are going to move together, so you need to ask question from you, why this block is going to move in this direction, why it's moving in this direction. Understood? Who is making it move? That's it. So where is friction? On the upper block. It's like this. This is the way to find it. Clear? Right. Okay, students, then see you tomorrow morning. Work for energy. Okay? All right. See you. Bye bye.
Thank you, sir.
Thank you.